Good afternoon. Can you hear us from home? Those online, could you please just write in the chat if everything is fine? Thank you, Evelyn. Thank you. Thank you, those answering. Okay, let's start. Good afternoon, everybody. So welcome to this hybrid session. It means that we have some people here face-to-face and most of you are online. This time, this is the information session about the Master in Innovation and Research in Informatics. We call it typically MIRI. And before starting, since we will be recording this session that will be later available online, I would like just to inform you, all of you, that this is recorded, and also that if you participate at any moment with a question or activating your camera or your mic, you will be recorded, so please acknowledge this when participating in this session. So today I'll go through this information basically about the Faculty of Informatics for those of you who are not students or alumni of UPC or FIP. And then I will focus on the MIRI Master. This is a master with 4 specializations that you need to choose when pre-enrolling, okay? So it's beforehand that you already choose one of the specializations. These specializations span 4 areas or fields of the computer science. The first one is advanced computing. The second one is computer graphics and virtual reality, computer networks and distributed systems, and finally high-performance computing. The last part of the talk is about several aspects that you may be interested in, like the enrollment procedure, the grants and aids that we can offer, social life, and frequent asked questions, okay? So let's start with the first part about the faculty as an overall introduction for those of you who may not know it. This is the faculty belongs to UPC. UPC is the Universitat Politècnica Catalunya. It's a public higher education and research institution specialized in science and engineering. It's one of the leading universities in Europe and South Europe in the topics, and it's a pretty large one. Importantly, what I want to highlight about it, it's a public institution, so that it means that our values that drive all the decisions we make here is about social responsibility, sustainability, equal opportunities, and cooperation and solidarity. No? So there are no other interests than just trying to promote social good and the benefit of the society. UPC is a pretty large university with more than 23,000 students of Bachelor, then more than 5,000 Masters and more than 2,000 doctoral ones, right? So if you check the number of Bachelors, Masters, and PhD programs, we are talking more than 66, 81, and 45 respectively. One of the things that I always like to highlight about this is that in 2020, the turnover for research and development projects of UPC was way above 50 million euro. So this is quite impressive for a university, and indeed we are leading in Europe in raising funds from research and development, and one of the top universities in this field. Also, another strong point of UPC is the internationalization. We have many students that decide to study some of the semesters abroad, and we have a lot of links with other universities, faculties, countries that you may benefit as a student, as I will discuss a bit later. So at FIP, because this master belongs to FIP, is the Faculty of Informatics of Barcelona, which belongs to UPC. It's a pretty new faculty if we consider the inception year, which is 1976. So roughly speaking, 40 years. But in this time, this faculty is the spearhead of the faculties of computer science in Spain, and one of the leading ones in Europe, typically ranked among the top 10. The objective of this faculty, obviously, is to promote computer science and related subjects and its impact in society. For those of you not knowing much about Barcelona, the faculty is located in the outskirts, but Barcelona is not that big, so it means that you can reach the city center in 30 minutes by metro. This is the specific address in case you want to take a look. And also contact information, our website, fip.upc.edu, and our contact email for master. So if you have any further information or further question about the master, you can always reach us in info.masters@fip.upc.edu. Also our social networking, if you want to understand all the things around this faculty and all the community and what is happening, it's a good idea you follow us in the social networks. So FIP, as main mission, what it has is to provide education in informatics engineering. So this can be divided in two sub-objectives. The first one is to promote the dissemination of information technologies to contribute to society improvements and social good in general. For us, and well, in general, informatics is the mean to do something. It's not an end by itself. So informatics should be transversal and impacting in any other field, right? So that's why we want to disseminate and contribute to improvement, especially for social good and society. As an important thing, what we promote is a strong background in our students. So computer science is an area that evolves pretty fast. So there are always new frameworks, tools, languages that appear, but this is a science, right? And as a science, it has some common background knowledge that has not changed in many years. And it's important that the students build their knowledge on these strong foundations that any science has, so that whenever they reach a project that can be complex, they can build a solution sound, rigorous, and correct for the requirements at hand. For this reason, we prioritize lasting concepts, so things that are fundamental, things that you will be able to benefit from it always. So it appears a new framework. You can scrutinize it and understand how it works, just to map it to theoretical concepts that will not change whenever happens in the near future. Also, you need to be endorsed with horizontal skills. In this sense, we highlight 3 of them. To be effective when working, especially our masters are pretty demanding from the working aspect, so they require practices and labs and things, because all our courses have theory classes, like theoretical classes, but then all of them also have labs or exercises where you need to get some hands-on experience, right? This hands-on experience typically is conducted in labs and projects that take quite a lot of work, no? Also, it's important to team up with other people, especially big projects require to be built by many people, so team working is essential in computer science. And finally, to be autonomous and be able to learn on your own, and in the end be self-sufficient. One of the things that I want to highlight is the quality indicators that we can be proud of in our faculty. In the last years, it's been a trend to certify the quality of a master by independent third-party organizations that check the quality of the faculties. No? In this case, this is called or known as an internal quality assurance system. That basically people belonging to these agencies come to the faculty, talk to the students, to the faculty, the lecturers. They check the services, the lecture halls. They basically check absolutely everything, and then they issue a statement about the quality of these masters from an independent agency, not related at all with the faculty. In this sense, I must say that MIRI, the master that we are going to talk today, got the maximum quality label that is called ACU Excellence. And if we check the report that we obtain, the report always highlight 3 aspects, no, that I would like to highlight also for you, because this is what the agency thinks we do best. The first is the program learning outcomes. They evaluate very positively that the outcomes that the alumni got was very useful for the day by day after the master. So this is because basically, as I will present now, this master has a very strong research-oriented perspective. So it means that you will be presented to cutting-edge technologies, ideas, methods that are being developed right now, and then the students benefit from applying this in their day by day. The second thing is teaching staff. Our lecturers are researchers, so it means that they are pretty familiar with complex projects that are bringing innovation and research to the companies or to the organizations, and somehow the students benefit from it because typically our lecturers bring all this knowledge to the lectures. And finally, the learning support services and the resources provided by the faculty and the campus. Right? So the FIP is pretty large faculty in the sense that we have more than 2,000 students with 3 bachelors and 7 masters, more than 400 graduate students per year, for a total of more than 10,000. Indeed, our alumni is well known and is well located in positions, in jobs, in companies, not only in Barcelona, but all over the world. And strongly as well, our university has very strong ties with international universities and other countries that I will also discuss later. If we check our reputation by international rankings, independent from the faculty, I highlight these three, which are most probably the most famous and popular ones. In all of them, systematically, the faculty is recognized as the best computer science faculty in Spain and top 100 in the world. So after this brief introduction about the faculty and the university, we move on to the master itself, MIRI. MIRI means Master in Innovation and Research in Informatics. So you can imagine how important is innovation and research that it's in the title, right? So this is the focus of this master. So basically, this master promotes a strong and rigorous background in research and innovation in 4 fields. Okay, these are the 4 fields that I'm going to discuss today: advanced computing, computer graphics and virtual reality, computer networks and distributed systems, and finally, high-performance computing. As I said, this has been labeled with the maximum quality label, which is the ACU Excellence. And this master is a 2-year master fully taught in English. So it means that you need to provide a certificate with the at least B2 in English to follow this master. In these 2 years, the master follows this structure: 30 compulsory mandatory ECTS. Here, these 30 are common for all the specializations, because basically these ECTS, what they are providing is the basics to conduct research and innovation, how to do strong experiments, advanced concepts in certain aspects that are required to get deeper later in the specializations, and this kind of stuff. Then, depending on the specialization you choose, you will have to follow one or other 48 specialization ECTS. These 48 ECTS are basically specific for the specialization and go very deep in this topic. Finally, you have 12 elective ECTS. So basically, this means that you have some room to decide what you want to follow in this ECTS. I will explain later that this is perfectly fine to do this 12 ECTS with internships or working experience. And finally, the master thesis, which is up to 30 ECTS. So you have here the 4 specializations with their links. And if you allow me just to click on the first one to show it as an example, you will be redirected to the master's website, in this case of MIRI. In the master's, each specialization has a different URL, because even if they are the same master, the specializations differ too much between them. That's why we decided to organize it in this way. You have here relevant information like the admission and curriculum that I will cover now. And for example, if you go to the curriculum, always we structure it in the following way: per semester and colors. Colors are mandatory courses, are these orange, reddish, or whatever, and the blue ones are the elective ones. Master thesis is in green, right? So in the first semester, you need to go through these mandatory courses. These are the mandatory courses that they share. Most of them are shared by all the specializations. The ones that are shared by all the specializations are these ones: algorithmic methods for mathematical models. As you see, this is a basic concept to go deeper in mathematical models. When you commit research, mathematical modeling is key, right? The second thing is concurrence, parallelism, and distributed systems. This is again a common regardless of the specialization, because this core distributed part of systems and parallelism is also very much attached to research nowadays. The third one is this: statistical modeling and design of experiments. Again, this is focused on the design of experimentation. And finally, a course about how to conduct innovation and research in a proper way. So this means that you are introduced to techniques, how to be a researcher. What does it mean to research on a topic? These kind of things are dealt in this concept. The other mandatory courses here: randomized algorithms, advanced data structures, computational complexity, and combinatorial problem solving, are specific of the specialization. So these 4 change depending on the specialization you are. These ones are the ones that are specific for advanced computing. There is another common course, which is the seminar activities. The seminar activities is a course basically where you can do whatever you want related to the topic, and you can choose it as a seminar. Okay. So what is a seminar? Typically, is a course that it's given. A seminar is a talk that is given at the faculty during those days. During the semester, there are plenty. That if you attend, you are granted some ECTS for following it. So CIRI, which is these seminar activities, it's our course to facilitate that we can adapt the content to very new trendy things, right? Because sometimes you add certain courses to the curriculum, but then something very new or very trendy is happening. In the way that the academic curriculum is created, to make just a modification to add a new course can take a lot of time, no? So what we do is to acknowledge that we cannot predict all the trends that are going to happen in the future, so that's why we have these six ECTS in the form of seminars that you can take during the whole master, where every time that we find a topic, new element that is interesting, we will schedule a seminar, and then at the end, after you take some of them, you get the 6 ECTS. So it's a way to guarantee some flexibility to introduce very cutting edge or innovative things. And this is important because remember, this is a master in innovation and research. So we need room to adapt to changes dynamically and quickly. So then the blue ones will always be specific for the specialization. In this case, that remember that I'm in the specialization of advanced computing. We have algorithmics for data mining, game theory, VLSI, and complex and social networks. Realize that we have 2 general elective courses. Here you can take these ones with internships or professional experience. You can fill these ones with courses from another specialization or also with courses from another master. Okay. And finally, you have the master thesis. Okay, so whenever you go to any of these, remember that SMDE, MIRI, CPDS, AMMM, and CIRI, the seminar activities, is common regardless of the specialization. These courses, you will always take them independent of the specialization. Then depending on the specialization, the other mandatory and blue boxes change, okay? So also I forgot to say that here at the bottom you have some recommendations or advices of what to take for these 2 electives here. These are courses that you may want to take, or as I said, you can also do it with internships, working experience, whatever. Okay. So let's move to explain each of the specializations in detail. To do so, first I need to stop a bit and say that research and innovation is key in this master, okay? This is the trend or whatever makes distinguishable from the other masters. And this is a very important master for us because, as I said, UPC is a research institution leading worldwide in research, and therefore this is a master that is a master that many of our students take either to follow a PhD or to do later research and innovation tasks in research centers or companies that are very innovation oriented. Okay. As I said, UPC is top in this aspect. So we were top university obtaining H2020 projects and raising funds from it. We also have quite a successful history on startups, spin-offs, innovation and technology transfer. And here you have a link to know a bit more about it. And also via the Center for Development Cooperation at UPC. So one of the things that I would like you to consider if you take especially this master is that you do some research during the master. How can you take research? Well, basically you can contact your lecturers. Remember what I said, your lecturers are researchers, so that you can just simply get in contact with them, know what kind of research projects they are involved, and they typically will offer you opportunities to follow, to work with them, either via research grants, which are grants that you can apply as a student and then you can do research in a research group here at UPC, or the other option is with learning agreements, which is between the university and a company that I will explain later in more detail. So, as I said, research is key, and as you will see when I explain each of the specializations, this will appear all the time, no? Let's just start with the first one, which is advanced computing. So what is advanced computing? Well, advanced computing is that specialization that it's trying to bring you or to approach extremely complex computational problems from the theoretical and practical angles, right? And to do so, first you need to understand what are the limitations of computers, right? To this, you need to go to the fundamentals, because in the end, a computer is nothing else than just a system with a very specific way of working that it's physically limited, right? So it's not that you can skip the limitations, or at least till we reach quantum computing, right? We are limited by the current architecture of current computers. So you need to acknowledge what are these limitations, understand the fundamental principles behind it, and then develop novel or efficient solutions that will be able to provide you with cutting-edge solutions with your very deep understanding of how a computer works and all their limitations, right? Let me put you here some applications where advanced computing is happening, because you may have the feeling that, okay, this is not something that happens in day by day, but there are plenty of examples in day by day that where advanced computing is necessary. For example, in intelligent systems, if you try to, for example, decide what is the route that track delivering all the online shopping that people did in Barcelona in one day, it's complex to decide in which order you need to stop and provide this information and provide each customer with the parcel that they bought, right? But if you look at it from a theoretical point of view, this is a well-known problem in graph theory, where you need just to follow certain points, which are some of them connected, no, via edges, and you need to follow this visit all these points with what is called the shortest path, which is basically means that you need to explore the minimum number of edges, yet visiting all the nodes, right? The problem is that many of these problems are known to be extremely or very expensive from the computational point of view. If you are a bit familiar with the computational complexity, this means that they are NP problems, right? NP problems means that you cannot fully explore them with brute force. You need to have some kind of smart algorithms that are able to prune the search space and just try to decide which are the best opportunities when exploring, no? And this is what in advanced computing you will be endorsed with, no? It's kind of very advanced algorithmic skills that will be able to impact on those kind of those kinds of problems that without this knowledge you could hardly, or people would feel very limited, no? Because this is very strong or complex problems that with the solutions or the knowledge that you get in a regular bachelor can hardly get to, right? Another one is social networks. Again, social networks can be seen as a graph, and then you can find whatever problem related with graphs and the graph theory and solve very big problems like finding which are the most influencing people in social networks like Twitter, which are the people itself, no? So only by representing people like nodes and their connections with edges, you may want to infer things like what is the influence of a node on all the others, no? And if I'm a company that I need to do a marketing campaign, most probably I want to identify them, no? So they do the next video with my product on the table or whatever, right? So this is again graph theory and application of graph theory and their algorithms. You also will learn here about machine learning and data mining. Machine learning and data mining is the way we have nowadays from a computer to learn from data and make decisions, no? Somehow, if you want me to present it this way, machine learning can also be seen when you don't know what code you should generate. So you provide the system with examples, and the system from these examples learn a model. What is a model? You can think it as a code, no? It's a set of statements with if-else or something much more complex, no? So this can be learned when a problem is hard. Then via data, I can learn the code that can solve this problem based on the solutions that I provide to the system. Human language processing is also considered another advanced computing problem, is when you have natural language processing, how to deal with it, cloud and web technologies, advanced algorithmics, game theory, and so on and so forth, okay? So what is the opportunities that this specialization is providing? So the first thing, there are 4 big groups of research groups that are tightly related to this specialization. So the first one is called Algorithms, Computational Biology, Complexity, and Formal Methods. The second one is Center for Language and Speech Technologies and Applications. The third one is Logic and Programming, and the last one is Relational Algorithmics, Complexity, and Learning Laboratory. So this would be the research groups where you most probably will be related during your master, if you feel like doing some research with them, or also during your master thesis, right? If you Google or just go to the UPC website and look for this, you will find the websites, and you can get also inspired of what kind of research they do and if this is appealing for you or not. The next one is the job opportunity. So the alumni of this specialization, where do they go? So since it's a research and innovation master, you will see that most of the things that I'm going to present in most of the specializations are either universities or research centers. No? So from the university point of view, we have alumni of this specialization in local and international universities. We have people working in big tech companies like Google or Amazon, in CAD companies like the ones here mentioned, and also since you need also a very strong aspect of efficiency from the coding point of view in data science, here there are some companies with big data science departments that are also hiring students from this specialization. So I also list here 2 exemplary master theses, what the students of this specialization do, right? So the first one is by Josep Sánchez Ferreres and advised by Josep Carmona and Lluís Padró, who are lecturers of this. I decided to keep the advisors as well because another way to learn if you may like what they do here is just Google them. All the lecturers as researchers, we appear in research websites. So you can see and see the papers or projects where they are participating. For example, if you go to the Futur website at UPC, F-U-T-U-R, Futur like future in Catalan, there you can look for any lecturer at UPC and you will learn in which projects and papers and everything is participating, no? And it's a nice way to know if this can be of your interest. So this thesis from Josep, basically what it was doing is modeling business process management in a way that was easy to companies to adopt them. What does this really mean? So in a company, the operations of a company can be seen as a process. A process is a task that happens, and when this task finishes, another one starts, and so on and so forth. No, it's a set of tasks which dependencies from one to another. So the thing is that modeling the processes of your company is important because if you are able to model your processes, you will be able to then later, via analysis, determine bottlenecks or inaccuracies, inefficiencies, or things that are happening in your process. So modeling is the first step to analyze the process and benefit from this analysis, making better decisions. But the problem is that modeling processes is pretty tough in a company, no? So what Josep did, together with his advisors, is that via natural languages, so the people were describing what a task was, they were inferring and formalizing the process. So the BPMN, or business process management, is nothing else than a formalization to formalize processes. So here, from textual descriptions, they were generating the formal definition of the process inherited from these textual descriptions. And just to see the impact of this, what Josep did is the master thesis is now the seed of a spin-off that he co-founded with one of his advisors that is called Process Talks, which also entails a patent, and Josep on the way also got a PhD and published in top journals and conferences that I will list here. Another example would be that one from Juan Pablo Royo, advised by Edelmira Pasarela, María Esther Vidal, Cristina Zoltán. María Esther Vidal, for example, is not a lecturer from the faculty, but this is something that happens quite often in our masters, is that our lecturers have connections and collaborations with people from other countries, and then you may end up during your master thesis collaborating with someone in another country, which is always good and interesting, right? So here, basically what they wanted to do is an algorithm to incrementally enumerate bit triangles in large bipartite networks. So if I enumerate it like this, maybe you don't see what is the application of this, right? But if you think of it the following way, when you are in a network, basically in a network there are patterns. And identifying patterns can be interesting because these patterns may hide fraud, problems, inefficiencies, right, like this, right? So one of the typical patterns that we look for in general when doing analysis is triangles, because basically what you are identifying is 3 elements or nodes that relates to each other in a loop, like in a cycle. So this kind of, if you are talking about people, is people that know each other, no? And then depending on what, this could be a kind of a source of fraud, right? Or any kind of other interpretation that you may give there. Bit triangles is triangles that are just, it's a pattern that based in triangles, okay? But it's, in the end, what they were doing here is providing very efficient algorithms that if you have a very large network, and this network could be the network of communication of the antennas that you have in Barcelona for providing the service of mobile phones, to analyzing a social network or whatever that can be represented as a network, finding patterns in an efficient way so that you can make decisions afterwards, right? Why this is interesting? Because networks and graph theory in general is very expensive. So being able to efficiently identify patterns inside a big, large graph is hard. Okay, so all these kind of algorithms typically fall in the research aspect. So Juan Pablo published this paper and he's sustaining the software. So there is a product out of this master thesis that can be used. Here, many times also you will learn other non-traditional languages like Haskell that are pretty interesting for certain projects. No? In this case, for example, this project is implemented in Haskell, and you have here the GitHub of Juan Pablo and all the software he produced, that it's an interesting outcome of this thesis. And with this, we move to the second specialization called Computer Graphics and Virtual Reality. So this is about the state-of-the-art computer graphics. And please do not think of graphics only as video games, okay? So there is life beyond that. And here you have a few examples, okay? So this specialization, what is trying to do is design efficient algorithms and solutions for real-life problems where imaging can help, right? And you can think here of whatever. So one very popular trendy thing about imaging and computer graphics is cultural heritage. This is quite trendy right now nowadays, no? Museums all over the world or certain monuments, what they are doing is just providing an online experience, like if you were visiting the museum of the, or the place, no? So this means developing virtual reality to improve the experience of the user. So another option could be creating an avatar just to experience with it whatever you do, trying new clothes, experiencing how would you feel in a crowd, things like that. Simulations and kind of simulating different scenarios. Also in the health aspect, this is quite trendy. So many of the work that they are doing in this specialization is in the health aspect. Also in urban design, what would be the impact of having a building this way or that way? What would be the feeling of the light? These kind of things that you can test before it happens, right? So what are the opportunities of this specialization? Basically, participate in research projects. This is common in all the specializations. You will see that I will be mentioning it. So the leading group here at UPC in this kind of topics is VIRVIC, that you have here it listed. So you can also do the thesis with them, participate with these international collaborators. Basically, in this step, always very naturally, you will end up co-authoring research papers or things that are related with innovation and research. And here you have the topics that you may find, no? For example, advanced 3D graphics, procedural modeling, real-time rendering, immersive interaction, geometry processing, and so on and so forth. No? They are tackling any advanced or state-of-the-art aspect related to computer graphics. So if you wonder where alumni ended up here, you have a list of companies and research centers and universities where they are there. Again, if you realize we are talking about universities or research centers, no? And you have video games, you have providers like NVIDIA or technological companies like Google, and of course, a first set of universities where the alumni are nowadays, right? Here you have two exemplary master theses. The first one is what I mentioned you is this trendy topic about cultural heritage and how to improve the experience of people that maybe cannot travel to another country, but yet would like to experience exploring a monument or a museum or anything, no? So this here you have a master thesis from Arnau Farràs that is called a web XR-based platform for mixed geometry-based and image-based exploration of cultural heritage models, where you basically interact with the environment. No, it's not only that you need to create the imaging, but you also need to provide means to the user to know more about a certain aspect or whatever. Just provide information and interaction. This was published in the Eurographics workshop on graphics and cultural heritage, and as I told you, it's one of the hot topics nowadays in computer graphics. The other would be the visualization of ensembles of molecular simulation trajectories. Sometimes there are problems that we don't have enough input to tackle it or to analyze it. So sometimes what do? So basically we try to simulate, and with the simulations we try to then find patterns or things to learn to these problems. No? And here we have the problem that sometimes we don't know much how certain drugs or certain medicines may impact, or how this molecular simulation of trajectories that would happen inside a body of a person. No? So in this case, computer graphics are useful for this kind of simulation, visual simulation. And this is a master thesis by David Duran that was published in a top venue like the IEEE Transactions on Visualization and Computer Graphics. The third specialization is computer networks and distributed systems. That you see that there is an and here, so it means that we are tackling two things here, right? The first one is computer networks, and the second one is distributed systems. They are different things, even they might look like similar. The first one, computer networks, is considered to be a set of devices that allows us to move data across nodes, including documents or whatever. No? So examples of computer networks could be the internet, the 5G, the mobile networks that are pretty trendy nowadays, cellular networks, sensor networks, optical networks. There are plenty, right? And the point is how we can improve from the hardware and the low-level aspect all these computer networks. No? So what kind of topics are covered here? So trends in the evolution of network architectures, how to improve routing and so things move around in the computer network, how to remove bottlenecks or how to generate backbones from it, the 5G architecture that now is very trendy. No? 5G should enable that in the future we will be connecting or interconnecting billions of devices. So in this sense, it's challenging from the architectural point of view, no? How to support all this, and so on and so forth. These are plenty of examples. Another one pretty trendy nowadays because of data science and artificial intelligence is data centers and clouds. How to make them efficient and deliver data as soon as possible. On the other hand, by distributed system, what we understand is a computing environment with several components, okay, spread across multiple computers on a network. And this distributed system acts as a system, but it's not located in a single place, but distributed across a network. Okay. So examples of distributed systems would be the DAP, obviously, no, internet is fully based on that. P2P systems, network file systems, distributed cache system, distributed databases that nowadays are basically inherent in big data. Blockchain is another kind of distributed system. And the topics that you would cover here is basically how to make these systems more efficient and work better from the architectural point of view. So what are the opportunities here? So work on research groups related to these topics where you can take your master thesis, you can do research in the studies. The research groups related to this specialization are the following ones: statistical analysis of networks and systems, distributed systems group, the virtuous group that is about virtualization and cloud computing. This is basically infrastructure for the cloud. broadband communication systems, and finally the high-performance computing system. Okay. You have the links here and further information that then when I forgot to say, as I always forget to say, that this is a presentation together with the slides will be available in the next week, so you can then follow the details in the slides. 2 exemplary master theses here. One, how to apply blockchain to secure a distributed set of clusters. So here the problem is, and the student Pau Marcé, together with his advisors, Beatriz Otero and Eva Marin, basically we're trying to go beyond the state of the art on what is called today the certificate authorities, the CAs that you most probably had to configure at some point with your laptops, right, or your systems. So this centralized view is challenging when you are going to connect billions of systems into the networks, right? So they were exploring how to decentralize these decisions via blockchain. This would be the objective of this first thesis. The second one would be how to calibrate low-cost air pollutant sensors using machine learning techniques. No? And this is by Pau Ferrer-Cid, and you have here as advisors José María Barceló and Jorge García Vidal. The abstract is basically that there are, this is a problem nowadays in society, there is a lot of pollutants in the air, so the problem is how to assess or use machine learning, in this case, to calibrate these sensors for measuring pollutants in the air. So this is a work that was analyzing it from the short term, the long term, and how to use sensors. Sensors in the end is IoT, It's when you just want to put a lot of information that it's generated individually, separately, and put it together to make knowledge out of it. And the last specialization is high-performance computing. Basically, high-performance computing is one of the topics that has been acknowledged by the European Commission and one of the hot topics to the vote in the next years. Together with data science, artificial intelligence, high-performance computing is one of these pillars identified by European Union. That's why this specialization is aligned with the European Master, the EU for HPC, which is related to this specialization. So HPC is trying to find groundbreaking scientific discoveries in the way that for very big problems that are known to be very complex from the computational point of view, how supercomputing can help and break this barrier, right? So we have problems related especially to data science, artificial intelligence, and so on, where without a supercomputing we could not compute, right? We are talking about simulations in the space. Imagine just from this point in the space you have billions of objects that have been identified, that they are moving all together, so whenever they want to do simulations at this scale, supercomputing sometimes is necessary. Or when the space is so big because you cannot prune it in any way, that you need to do a lot of brute force to generate a lot of combinations. This happens a lot when they are trying to look for the causes analysis, genetical analysis of samples to identify reasons or patterns that might cause cancer, for example. Okay, since we don't know how to look for these patterns, what you need to do is brute force. Let's see if I find a pattern that is common in all the samples I have, right, from a genetical point of view, and then you start experiencing by brute force. In this case, you need something like a supercomputer to be able to generate or analyze all these combinations. So the kind of places where you can apply supercomputing nowadays is varied. So here you have some of them in research labs. Obviously, in research labs they are always trying to tackle very complex problems, and naturally they end up in the supercomputing field. Here we may talk about renewable energies, understand the evolution of our universe, predict and track storms. This is very complex, problems that really need a lot of computational power. Media and entertainment, so in the sense of HPC to edit features, films, render mind-blowing special effects, these kind of things that again requires a lot of computing. oil and gas, how to predict, drill, and extract oil and gas. This is, again, a complex issue. Artificial intelligence and data science or machine learning. Also, there are problems especially related with deep learning, which is especially the killing factor, no? Nowadays. Deep learning, you can consider it as the brute force technique in data analysis, right? So it's basically learning from millions and millions of evidences, learning a neural network, no? And here, this is very tough to train these kind of models, and sometimes we need high performance computing to generate them, and financial service, and so on and so forth. So what are the opportunities here? So there are basically 4 groups or centers that are related to this specialization: the ARCO group, CAP group, Virtuos group, and then obviously associated to UPC, the Barcelona Supercomputing Center, no? Which is the center where HPC is taking to the extreme. The professional opportunities that the alumni typically get here is participating in the design of future processors, supercomputers, mobile systems. You may have heard of Lagarto, no? This new generation chip that is generated in Europe, trying to compete with Asia, China, and Taiwan, that are the leaders in chip producers. So now Europe is trying to create and bring the know-how of creating chips, something like as important as creating chips to Europe, and Lagarto is the initiative that BSc is participating. Develop supercomputing applications. So now that the supercomputing, you want to explore the supercomputing to solve a problem, how you need to code there. It's not like coding in a regular language, no? They have their own ways to pass this information to the supercomputer, and one of the things that you need to learn is how to develop these applications. Improve performance in general, develop and optimize application kernels, and develop tools and compilers, because in the end, a supercomputer is a system very efficient, but it's a system that we need to keep tuning and improving every time. So I took 2 exemplary master theses, one related to the research groups that I mentioned before, the other one to the Barcelona Supercomputing Center. So the first one is by Joel Sanchez, advised by Roger Esparza and Miquel Izquierdo, titled Analysis and Optimization of a Debug Post-Silicon Hardware Architecture, right? So is it possible to try to analyze what is the possibility of having hardware that is not based in silicon, which is the basic of what we are using now, no? What would be the new materials and opportunities in the future to develop alternative things? The second one, by Marc Solé, advised by Leonidas Cosmidis, called Hardware Software Co-Design for Low-Cost AI Processing in Space Processors. This is a typical application of HPC. When you have an AI or data science topic that it's very hard to train, like a deep learning system, how can we benefit from high-performance computing in order to train these systems? This requires a completely different approach, because data science was born in regular servers or regular computers, and we were used to simply running algorithms, but deep learning opened a completely new way, very complex and demanding from resources point of view, way that requires to benefit from other kind of hardware, like GPUs, FPGAs, or brought to the extreme, supercomputing, no? High-performance computing. So as you saw, there is plenty of innovation, no, in these 4 specializations. This means that regardless of the one that might interest you during the master, and very likely during the master thesis, you will be doing innovation and research either with a research group or a center. So most probably you will need to conduct an internship. So the way to do internships at the faculty is via Convenis de Colaboració Universitat Empresa, what we call CCE. You may want to follow this link to know more, but basically you here have information how to do internships via this model. There is the information for the companies, for the students, and the regulations. Basically, this is a win-win for everybody. The companies like it because they don't pay almost no taxes to hire you. And on the other hand, we guarantee that you are paid a minimum amount of money per hour, just to guarantee that you are in a good setting for learning. So in this master, CCE can be established between companies and FIP, and you can take up to 900 of internship hours, okay? Without accounting the master thesis. Then later you can do the master thesis also as an internship for an additional 450 hours. So in total, you may go up to 1350 hours of internship in this master, okay? But you need to distinguish the hours that are part of the master thesis from the rest. As I also mentioned at the beginning, you may also convalidate the elective ECTS. Remember that there were 12 in this master, with internships or working experience, as I will explain in a while. And if you want to do the master thesis with this modality, this is what at the jargon faculty we call it modality B or D. Modality B is an internship at a company, and a modality D is a internship on a company abroad. Okay? The rule of thumb that you need to follow here is that 30 hours of work at the company translates to 1 ECTS. Okay, so the minimum number of ECTS you may need to recognize is 6. You cannot go below this, and you cannot go above 12. For the professional experience, you can also, maybe you are not interested in signing an internship with a CCE, then you may have your own working contract. Then basically what you can do is that this experience work that you did previous or during the master can be acknowledged. And the rule is this one, 1600 hours are equivalent to 6 credits. And then if you do more hours than that, then you need to go proportionally to know how many credits you may get from it. So in short, you can establish an internship with a CCE and then do up to 900 hours per year, right? Or the second thing is as professional experience, no? Via your working contract. About mobility and internationalization, as I said, this is one of the strong points in our master. In this sense here, it's also easy because many of the research groups here have contacts with other research groups in other universities, and you may be interested to do the master thesis there in a collaboration between your lecturers here and there. There are plenty of agreements, up to 189. And here for MIRI, you can go out for 30 ECTS of lectures plus 30 CTS of the master thesis. So in MIRI, you can go for 60 CTS, okay? So, but 30 would be typically the third semester, and then 30 more for the master thesis. You typically go abroad in the second year, okay? We have plenty of mobility programs that you may want to check online. Many of them come with scholarships, so you are paid when also granted the position. With CERN in Switzerland, typically in summer, but then with Erasmus+, frameworks in Latin America, USA and Canada, with Japan and also China, okay? And finally, we have 2 double degrees with the two places that I mentioned here, one university in Peru and the other one in France. You can also go with an internship abroad. You can go to another company in another country and formalize it with an internship abroad via mobility. And finally, other activities like summer schools and short stays. So this is the URL, the website where you can know more about the mobility. If you follow any of our masters, you will be an FIP student, so you need to check the outgoing thing, which is the regular mobility. And if you want to consider an outgoing to do a double degree, would be this icon here, okay? It's pretty detailed, all the information here, so just follow it. There are 2 things that I would like to warn you about mobility and internationalization. The first one is the mobility calendar is very well ahead in any of the cases. It means that mobility, the only down part they have is that it's very bureaucratic. There is a lot of red tape. So it means that you need to start well ahead, okay? So what does it mean? That you need to pay attention and keep an eye to this link here, the mobility calendar. This mobility calendar is live, and we always are announcing you what are the calls that are open. Be sure not to miss the deadlines, because you miss a deadline, you will not be able to participate in the framework you are interested in. And since we know and are aware that there are a lot of information related with mobility and internationalization, we always organize 2 information sessions, one mid first semester and mid second semester. So this year the dates were mid-November and mid-February. You can expect something similar next year, that is when you would need to check mobility. Nevertheless, if you are planning to do mobility, it's advisable that from the very first day you make this explicit and let know our colleagues taking care of the international relationships, so they can always warn you and be sure you don't miss a deadline. So you can always contact them at this email address. Well, what to do if you are interested in MIRI? Well, the enrollment procedure at UPC is always the same, regardless of the master and regardless of the faculty. It's common for the whole UPC. It goes by 6 different steps. The first one is register and entering your personal academic details. Basically, it's a form that you need to fill. When you end up filling this form, you need to pay a tax of €30. And at that moment, your application is sent to the admission commission. Okay? They will check your application and they will determine if you are have a good background to follow the master or not. When they emit their decision, you can check it online, and importantly, you must accept the place. So the position that you were granted, you need to explicitly accept it. Okay? Otherwise, we will understand that you are not interested in master. So it's important that you accept it. Besides saying yes in the web, you need to do a second thing, which is paying €300 just to secure your position in the master next year. These €300 are deducted from your enrollment fees. So whenever you enroll, it's not that you need to pay the whole fee, but we deduct these €300 you already paid to secure the position. So the last step is enrollment, the proper enrollment, where you pay the rest of the taxes and choose the courses you are going to follow next semester. So there are two admission periods. The admission periods go from 1st March to 27th of May, but we divide them in admission periods because if you apply before the 22nd of April, we answer by today if you are admitted in a master or not, but this has already passed, so now you need to check the second period. The deadline is 27th of May. Be sure not to miss this one, okay? And then you tentatively you will be answered if you are accepted or not by 3rd June, okay? If there are available positions in the master, we open a 3rd period after this one that might go till 13th of June, and then you would get an answer by the 7th of July. To check the admission criteria, follow masters.fib.upc.eu and then choose the specialization you like the most, for example, this one, right? And then here you have the admission information for this specialization. So here, just at the besides telling you what are the required documents, you have the selection criteria, so what they are going to check and what kind of profile you are expected to have, right? So carefully check it to know how you are going to be evaluated by the commission, so you can provide all the information they may be expecting from you, okay? To pre-enroll, at the end of the website I was there, if you just scroll down, you will get to this screenshot I put here, where there is this pre-enrollment button. When you click here, you start the first step in the UPC process I showed you before. So here is when you entered all the information. And importantly, only when you have entered all the required fields, the button to pay will be activated. You will not see it before, okay? So it's not a mistake. It's just you're missing to introduce some data. So you pay the €30, and then it's at this moment that your application is sent to the committee that will evaluate your application, okay? What happens during the admission? So the committee, in this case, let's focus on the second period because the first one has already passed. You may get one of these answers: accept, waiting list, or reject. Accept means that congratulations, you are in, you have a seat in the master next year, so you need to move to pay the €300 to guarantee the position, and then you will be informed when to do the enrollment. Enrollment this year will be the last week of July, okay? Waiting list means that if there are more people applying that positions in the master, we will prioritize those that will be accepted directly, and the other ones will be put in a waiting list. Being in the waiting list does not mean that you don't have any chance. Always, by different situations, people may change countries, may change work, may change ideas or whatever. Some of them who were accepted decline the position. So then we contact the people in the waiting list so you can be accepted eventually. If you are rejected, means that we saw problems in your background to follow the specialization you chose. Remember that when you enroll, you need to choose the specialization in this master, so it's chosen from the beginning. And basically here in words, I explain in text what I just said by words. No? What is the meaning of being accepted, waiting list, or rejected? So what are the prices that we expect for next year? Are these? These are the current prices for this year. The prices you could pay for next year will be published in July. But we know that we are expecting exactly the same prices or even lower. Okay, we will see if they even go lower than this. So you, just to be in the safe side, just make the numbers counting with these prices that are different for European Union applicants or non-European applicants. If you want to know more, feel free to drop us an email, okay? If you want to know more about procedures, I don't know what kind of certificate I need to upload here, when it's going to be answered, whatever that is about the procedure, write to info.masters@fib.upc.edu. If your concern is my background enough to follow a specialization? Is my, what is the objective of this course that I don't really understand? Anything that is purely academic, contact the specialization coordinators, which are the 4 that I list here. It's different per specialization, and you have the emails to contact them. I also included here the websites for each of the specializations and also the academic calendars, because a usual question that you have is, when are breaks, holidays, and this kind of stuff? Well, you can check the calendar of this year, and the next year will be something pretty similar. It doesn't change much, okay? So about grants and aids, the faculty has some grants to help people follow our masters in case of financial problems. They will be in this website here. They are not updated yet, because typically the grants information or the grants need to be applied after you've been accepted in a master, no? So it's too early yet for the grants. That's why you will find here the information of the previous year, but the grants will appear and will be published duly on time when they are available in this link, so keep track of it. About grants, there is a generic grant for Spanish citizens by the Ministry of Education that you need to be aware of. This master, the master of MIRI, can benefit from these grants. Basically, you need to apply before the 12th of May, so very early. And basically, you need to apply without knowing to which master you are going to follow, or even if you are going to do a master next year. But the thing is that they did it a procedure that you need to apply now, where they will check your financial background and your marks from your bachelor, and they will decide if you are green or red light to follow a master, to get a grant. And it's only in September that then they will ask you, which master are you going to follow? Okay, so it's kind of 2 different procedures, and the first one, the deadline is 12th May. If you miss this deadline, you cannot apply for a grant. So please check the information related to these grants, which are in this link and this video, and be sure not to miss the deadline if you can apply, because it's a good help that you may consider. Finally, the community is very vibrant around the faculty. We have plenty of social activities, most probably led by the students' associations. These associations are run by our students, so the faculty or the university do not do anything here. We only back them up, right, because it's our interest that they feel comfortable and they grow. But associations are run by students, and they generate a lot of events. Like, for example, today it's starting Hack UPC, and it's taking place this weekend. This is the biggest hackathon in Europe, and a very big effort from our students who organize and do all the work here. Others like the Game Jam in Barcelona. So there are plenty of activities that they organize, and if you happen to be a student of the faculty, please consider it, because I think it's good what they do. But besides what the students do, there are plenty of other things also from the faculty and the administrative staff that they organize things. Another interesting one is the hackathon that we organize every year for social good with la Marató de TV3, which is called Bits per la Marató. Other ones are events promoting women in data science, like the Women in Data Science Barcelona 2021, or Top Secret Roses, which is a similar program. Summer schools, there are plenty of summer schools. A summer school is an organization that during a week you go there and there are cutting-edge talks about a certain topic. For example, this is a summer school about big data and data science. So during this week you have reputed people that go there and talk about something very new, very trendy that is happening. It's a way to keep yourself up to date, and you can get also elective courses after all from many of these events. Another one are events like Industry 4.0, like the Advanced Factories, the FIP Visiona that tries to put in contact the students with companies, and many others. So just keep an eye to our website, where we always promote this kind of events. And finally, some frequently asked questions that you may have about this master. Now. So typically questions are, if I'm not finished with my undergraduate studies, can I apply to a master? And the answer is yes. So most of you will finish the bachelor in June, July, right? And we acknowledge that. So you need to apply anyway now to start in September. And what we will do is that the admission commission will check your current transcripts, your current marks, and your current situation. We will be expecting you to finish the bachelor before starting the master. But even if you still miss the bachelor thesis, you still can enroll now. There is a special procedure, and if this is the case, you need to finish the bachelor thesis before October, but for 1 month you will be doing the master without being finished the bachelor. This is fine, this is acceptable, but this is an extraordinary option that you better contact us to let you know how to do it. But in general, it's fine that at the application moment you are not done, provided that you finish the bachelor before starting the master. Can I work and study at the same time? Big yes, right? I would expect from you that you work, you do internships, you do research. Just improve your CV, Take advantage of all the opportunities that this faculty and this university put for our students, which I think is good and a very different aspect compared to other faculties and universities. And what about COVID? Well, hopefully, I would not say it's past because it's still here, but at least we are just going back to normal life. We have done this academic year with masks. Now it seems that we will be doing it without masks, but in any case, I would expect that the lecturing will be face-to-face next year for sure, or almost for sure. And what about incoming students? What about enrollment? When I told you, remember that enrollment will happen the last week of July. So what does it mean? If we are the last week of July doing the enrollment, it may happen that some of you, especially if you are abroad, you cannot come to Barcelona. It's not a problem. Enrollment is online. Okay? And the only thing that may happen is that when you enroll the first time only, the Secretariat may ask you for some original documents, but then they will allow you to do the enrollment still online, and they will ask you to bring these documents when you come face-to-face to start your master in September, okay? So, in principle, this is a thing that should not be a problem, that came because of COVID, and it's staying, this online enrollment. And that's it, what I have prepared up to now. So if you have if you have questions, we can start from here. Basically, let me just present the slide where we have all the contact information with the advisors of, in case you are interested in that. I will leave it here. This one, I know. This one. I will leave this one here in case you want to copy any email. So we will start with questions from the audience here, and then please, those online, you can start writing your questions in the chat. You have two options. You write your question and I will read it and then provide an answer, or you can just write the word question, and then when I name you, please unmute and talk via your mic, and I will answer afterwards. So while you write your questions online, we will start with people here in case they have any question. Do you have any question? No. Okay. So what about online? Do you have any question, people online? Aaron is asking in one of the slides, let me go to the slide and clarify the mistake, because I realized that I made a mistake. Let me clarify it. It's here. It's in the procedure. Oh, no, I know what it is here, no? Here is this note here, right, Aaron? So this is a mistake. This should not be here. This master is not equivalent to, is not an habilitant master. I will remove it from the slides that I will make available for you. Is not the case. Okay. In any case, what this still holds and is true is that when in the beca del Ministerio you apply for it, you need to choose master no habilitante in order to, because in this kind of grants they distinguish between master habilitante and master no habilitante. All the masters in our faculty are no habilitantes because the profession of informatics is not regulated like the other engineering. So it's easy, always no habilitante. Sorry for the confusion. I will fix it in the final slides that we will share with you. Thank you to you for spotting it. Any further question? No? All set? All clear? Okay, then, oh yes, final last minute question. Isabel is asking if I plan to work while doing the master when I have to indicate that I would like to do the master in more years. So Isabel, this is what we call part-time studying. So whenever you enroll, you need to specify that you are going to be part-time student. Then instead of enrolling 30 ECTS per semester, you need to enroll at most 18 or at least 18. Okay, so which maps roughly speaking to 3 courses per semester. Then you have an extra semester to finish the master. In this case would be 2.5 years. Okay, expecting to enroll at least 18 ECTS per semester and doing the master thesis in 1 semester. This is the usual. So answering this is at the moment of the enrollment in step number 6 of the procedure I show you in the slides is when you need to specify you are going to be a part-time student. Is that clear, Isabel? Thank you for your question. Any other last minute question? Don't be shy, it's for free. Okay, so then the only thing that is missing from my side and on behalf of my colleagues that also behind the masters, so we are a group of people. Thank you very much for attending. Thank you. Oh, last minute question. Mikel is saying, will there be an open door day in order to visit the faculty? For the bachelor it is, but not for the masters. We don't do this for the masters, Miguel. So I don't know if you are interested in seeing the campus and the facilities, maybe you can enroll in the open day for the bachelor. I don't know if this is possible. Maybe not, no? Maybe not. No, we typically don't organize this for the masters, sorry.
No.
Is it about the, what would you like to see? The services, the campus? Is this what you are considering? Or something more kind of a guided tour with explanations like the presentation today?
Según para mí, si m'escriu i faig una tour. No diu res.
See the campus and that stuff. I mean, the campus is completely open in the sense that you can come and move around. Just check the address that they put at the beginning of the slides. You can just come here and move around on your own, and the lecture halls are open. I mean, the only thing is that there is a lecture that don't go in, right? But you can just see the services and the labs, and everything is something that you can access without being a student. So you can also move around the campus without any problem. So if this is your interest, I think you can just come to the campus and move around with complete freedom. It's fine. Everything is open. No worries. So any other question? Okay, let's close then this information session. Again, to thank you, all of you, for your interest in our master, for taking the time to be here, and hopefully see you in September. So thank you very much again for your time. Bye.